Good morning, dear friends. Myself, Dr. Chandrakanta here. I am at College Malegaon Camp Malegaon. So, last lecture we complete first chapter of analytical chemistry, that is Introduction to Analytical Chemistry. So, in this video we start the second chapter, Calculation used in Analytical Chemistry. So, this chapter broadly divided in three important points. First is some important units of measurement. So in this topic we have to study SI units, distinction between mass and weight, millimole and calculation, significant figures. So this much part we have to study in first topic. Second topic, solution and their concentration. So molar concentration, molar analytical concentration, molar equilibrium concentration, percent concentration, part per million, part per billion, part per thousand, solution diluent volume ratio, P function, density and specific gravity of solution, and problem based on this concept. So this is the second topic of this chapter. In the last topic of the second chapter, that is chemical stoichiometry. In this case we consider this empirical and molecular formula, stoichiometry calculation and problem. So today's video we complete this first part, that is some important units of measurement. So let's start this first topic, some important units of measurement. So there are several methods to express the metric units of basic and derived physical quantities used in analytical chemistry. So generally the metric unit of physical quantities are expressed in System International, that is SI unit, known as a MKS unit system. So there is another or other metric unit system, that is CGS unit system, and it is also called as a common unit system. But this SI unit is a modern form of metric system and mostly widely used system all over the world. So this SI unit is used in all over the world. So we consider this SI system as a widely used system, unit system. So what is this SI unit? So this SI is a acronym for the French word. What is that? System International D units. So it is a short form acronyms of this word. So the scientists throughout the world use the standard system of unit as a international system of unit, that is SI unit. It is based on the 7 fundamental base unit known as below table. So first column is physical quantity, second column name of that units, and the third column is a abbreviation of that unit. So first quantity, physical quantity, is a mass. It is expressed in kilogram, abbreviation is small kg. Length expressed in meter, unit is meter, symbol or what we say abbreviation is m, small m. Time measured in second, symbol or acronym abbreviation is small s. Temperature in Kelvin, capital K. Amount of substance expressed in mole, so this small om, mol, mole. Electric current expressed in ampere, that is the symbol is capital A. Luminescence intensity expressed in candela, symbol is small cd. So another common SI, derived unit. So previous table is for basic, and now we consider this derived units. So area, this physical quantity is area, name of unit is square meter. This SI symbol is a small m square. Volume, the unit is cubic meter, symbol is small m cube. Density, kilogram per cubic meter, symbol is small kg per meter cube. Velocity, meter per second, symbol is small m per second or second raised to minus 1. Force expressed in Newton, capital N, this symbol is small kg, small m, small s raised to minus 2. Pressure expressed in Pascal or Newton per square meter. So this Newton per square meter is a capital N, m small m square, or it is also expressed in kg per meter per centimeter square. Energy expressed in joule, unit is small kg meter square per second square, or it is also expressed in small unit as a capital N and M. Molarity, mole per cubic meter, is mole per cubic meter, mole MOL m raised to minus 3. Molality, mole per kilogram, this mole per kg. Frequency expressed in hertz, symbol is Hz or per second. So these are the derived units. Previous table is for it is a basic unit. These are the basic units. These are the derived units, common derived units expressed in SI units. So now consider this some prefixes used in units. So these are the prefixes. They are abbreviation and multiplier. So when we consider this iota, express abbreviation is capital Y. What is the multiplier? 10 raised to 24 plus 24. When we consider this zeta, extra, peta, tera, giga, mega, kilo, what is the symbol abbreviation? Small k. Multiplier is 10 raised to 3, that is 1000. So when you convert this gram and kilogram, at that time this multiplier is 10 raised to 3 or 1000. Hecto 10 raised to 2, small h. Deca, da 10 raised to 10, sorry it is a 10. Deci, small d 10 raised to minus 1, that is 0.1. Centimeter 10 raised to minus 2. Milli, small m 10 raised to minus 3. Micro, this is the symbol micro, 10 raised to minus 6. Nano, small n 10 raised to minus 9, that is 1 upon 10 raised to 9 or 10 raised to minus 9. Pico, p 10 raised to minus 12. Femto, small f 10 raised to minus 15. Otto, a 10 raised to minus 18. So we go up to the yocto, that is small y. This is the capital Y, this is the small y. Yocto unit, this multiplier is 10 raised to minus 24. So these are the some prefixes used in units. So we consider some conversions, useful conversion. So what is 1 angstrom? This 1 angstrom is equal to 10 raised to minus 10 meter. 1 atomic mass unit is equal to 1.66 10 raised to 10 raised to minus 27 kg. Similar with this calorie, 1 calorie is equal to 4.184 joule. Similar with this liter. This temperature T in degree centigrade we converted into Kelvin. At that time what with the addition? 273. 1 atmosphere is equal to this much Pascal or 760 mm of Hg. 1 hour is equal to 10 raised to minus 7 joule. 1 centimeter square is equal to 10 raised to minus 4 meter square. 1 centimeter per cube, 1 centimeter per cube, it is equal to 10 raised to minus 6 meter per meter cube. So these are the unit conversion. 1 electron volt is equal to 1.602 10 raised to minus 19 joule. 1 ml, we measure the solution 1 ml. What is 1 ml? So it is a 1 centimeter cube. So after useful conversion, now we see this distinction between mass and weight. So major or most of the student, what do they consider? What is that mass? Mass and weight both are the same, but not. There is some difference between this physical concept, physical property. What are the difference? See, this mass and weight are the two different properties to express the amount of chemical substances. Both are useful to express the amount of substance, but they are different. This mass is the amount or quantity of matter in a material or object which remain constant regardless of where you measure it. So mass is a constant term. What is that? It is the amount or quantity present in object or material. But what is the weight? This weight is a force of attraction between an object and its surrounding earth surface. As this gravitational attraction changes with geographical location, the weight of an object depends on where you weight it. See, if this gravitational force increases, weight increases. If gravitational force is less, at that time this weight is low, or weight is somewhat less. So this weight factor, this weight physical quantity, this amount of matter expressed, it depends upon the gravitational force, and thus it changes with geographical location. See again, what is the relation between these two, mass and weight? So this relation is expressed as W is equal to mg. What is W? W is the weight of an object, m is the mass of that object. What is g? G is the acceleration due to gravity at that position. So this W is equal to m into g. So this m is a constant term. If this g is changed, this W is changed. So this g is vary due to geographical location. This weight of a object or matter it changes, but mass is a constant. Where would measure it? It is a constant term. So it is more clear in this point. When we consider this mass, what is that mass? A balance is used to compare the mass of an object with the mass of one or more standard masses. आपण तराजू पाहिला असेल. What is that तराजू? That is one type of balance. So it is used to compare the mass. In one part we place this object, whatever may be the object. In another part, what we place? We place the standard masses, 1 kg, half kg, 250 grams. So these are the standard masses. So we compare this object with standard masses. The standard masses are same. At that time, see, this acceleration due to gravity act on both. It act on the object, that mass of object, as well as this acceleration due to gravity act on the standard masses which is present in another compartment of balance. And thus this acceleration due to gravity act both the substance, this both the unknown equally, and thus this effect of gravity is not considered in this comparison. And thus it is identical to standard masses with which it is compared. So this mass of an object, it is identical to the standard mass with which it is compared. Suppose is it compared with 1 kg, this object mass is 1 kg. If it is compared with standard mass of half kg, so that object mass is a half kg. And thus this mass is a constant term. They do not change with geographical location, or do not change with gravitation. So it is a comparison between the standard masses and object mass. See, just now we clearly mentioned this mass and weight distinction. Mass is a constant term. Why? Because it is compared with standard. But in case of weight, this weight is changes with gravitational attraction, gravitational field of Earth. But see, this point, it is not correct. But this lack of better word for this mass or object mass, we will use this weight. So instead of mass, we say this is the weight of that substance when we compare it with standard masses. So it is for our convenience, for our better understanding. What is this way? So throughout this chapter, now we consider this weight. Way is for determining the mass. This way, what is the way? This is the procedure for determining the mass. What is this way? It is a comparison of object mass with the standard masses. That is called as a way of an object. And this weights, now this weight word, for a better word, we use this weights to means the standard masses used in weighing. So these weights are the standard masses used in weighing. So these are the weights. What is the weights? It is the standard masses. And now this way now we consider as the process of comparison of object mass with the standard masses, for our convenience, for our better word. And the last point is this mass and weight, this difference between mass and weight. So what is the first point? This mass is a measurement of amount of matter content in an object. What is the weight? Weight is a measure of pull of gravity of an object. Second point, mass is measured by using balance, comparing known amount of matter. So these are the balance used in comparing the object mass with standard known mass, standard mass. But weight is a measure on scale. This weight is measure on scale. the mass on an object does not change with change in object location, but weight of an object change with change in object location, because it is affected by G, that is gravitational force. But now we use these two words. This weight means comparison of object with standard masses, and these weights are the standard masses. Now the next concept is a mole. What is mole? It is defined as the amount of specified substance that contain the same number of particles. Same number of particle as the number of carbon atom is exactly 12 gram of carbon 12. What is the meaning of that? If we suppose take example of carbon isotope 12, carbon having mass number 12. So that type of carbon when we taken as a 12 grams, that carbon isotope carbon 12 we taken when 12 grams, at that time that whole 12 gram carbon atom, that weight, that specified substance contain is called as a 1 mole of substance. See, what is that? Same number of particle as the number of carbon atom is exactly in 12 gram. So in this 12 gram, what are the number of carbon particles are there? When we take same number of atoms of different element having the different mass unit, so that is the mole of that substance. So in this case we consider this carbon atom. So when we take this carbon isotope 12, so for that what we take? This 12 gram of carbon. That number of particle present in this 12 gram of carbon is called as a 1 mole of carbon. See, it is clear in above. Follow expression. What is SI unit? It is denoted by symbol MOL, small MOL, mole. This important number is Avogadro's number. What is the important this number? Avogadro's number. It is a N. We use this Avogadro's number N. A for Avogadro's. What is this number? 6.022 into 10 raised to 23. When we measure that carbon isotope 12 with 12 gram, at that time how many carbon atoms are there? That are 6.022 10 raised to 23 number of carbon atoms are present in this 12 gram of carbon isotope 12. That number is called as a Avogadro's number. The molar mass M is a substance in the mass in gram of 1 mole of that substance. What is molar mass? It is a mass of 1 mole of substance. So this molar masses is calculated by the addition of atomic masses. When we consider this molar masses, it is the addition of the atomic masses of that atoms appearing in the chemical formula. So whatever be the substance, that substance containing the atoms, number of atom, and for calculation of molar mass, what we consider this atomic masses of that atom present in that substance chemical formula. The atomic mass is the mass of 1 mole of atom. What is atomic mass? This atomic mass is a mass of 1 mole of atom, which is equal to the Avogadro's number. Again, if we take this 1 mole of atomic mass, at that time that number of atom present in that 1 mole is 6.022 10 raised to 23 number of atoms are present. See this example clear that above point. If we take this molar mass of acetic acid molecule, so what is the formula of acetic acid? CH3COOH. So this is the formula of acetic acid. So in this substance, what are this present? So there are 2 carbon atoms are present, 4 hydrogen atoms are present, 2 oxygen atoms are present. So this number of 3 types of atoms are present. Is the sum. What is the molar mass of acetic acid then? It is the summation of atomic masses of all atom in acetic acid. How we calculate this M, that is the molar mass of acetic acid, is equal to 2 into atomic mass of carbon. So there are 2 carbon atom, so 2 into atomic mass of carbon, 4 into atomic mass of hydrogen. There are 4 hydrogen atom, this 3 and this 1, that total 4 into atomic mass of hydrogen, plus 2 into atomic mass of oxygen. There are 2 oxygen, so 2 into atomic mass of oxygen. So this is the formula, that is the summation of atomic masses of all atoms present in acetic acid. We know this atomic mass of carbon is 12 gram per mole, atomic mass of hydrogen is 1 gram per mole, atomic mass of oxygen is 16 gram per mole. We put these values, we calculate, multiply it, then addition gives final answer is 60 gram per mole. So this 60 gram per mole is the molar mass of acetic acid. Similarly, we calculate this molar mass of glucose. What is the formula of glucose? Chemical formula C6H12O6. Now you consider this M, that is molar mass of glucose is 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. So multiply that atomic number with its atomic masses. 6 into 12, 12 into 1, 6 into this 16. After multiplication and addition, what you get, final answer is 180 gram per mole. So this 180 gram per mole is the molar mass of glucose. And thus this 1 mole of acetic acid has mass 60 gram. 1 mole of glucose has a mass of 180 gram. Now we consider this another unit is a millimole. Just now we complete these moles. Now we add this prefix milli to this mole, that is millimoles. What is this millimole? Sometimes this amount of chemical substance in mole is very small quantity. So instead of writing that small quantity, we convert this mole into smaller unit, that is millimoles. So it is more convenient to express this same quantity in millimoles and to make calculation with millimoles rather than moles. So instead of mole, what we use, millimole, smaller unit of that concentration. We use smaller units. It is symbolized as MOL. This milli is a common prefix used in SI unit, and this millimolar masses, small m is milli, capital M for molar mass. This millimolar masses is similar to 1 upon 1000 or 10 raised to minus 3 of the molar mass. So this millimole is molar mass divided by 1000, and thus 1 moles is equal to 1000 into millimoles. For example, if we use this 1 millimole of NaOH, we know 1 mole of NaOH is equal to 40 gram, but when we use 1 millimole of NaOH, it is a 40 milligrams of NaOH. So we reduce the scale, we reduce the quantity. So we use this smaller unit as a millimoles. Example, on the basis of this moles and millimoles, calculate the number of moles and millimoles of benzoic acid that are contained in 5 gram of pure benzoic acid. 5 gram of pure benzoic acid. This G is remain 5 gram of pure benzoic acid. What is given? This molar mass of benzoic acid is given, that is 122.1 gram per mole. So in solution, first point, this number of mole of benzoic acid is equal to mass of benzoic acid upon molar mass of benzoic acid. So mass is given 5 gram divided by molar mass, it is also given, that is 122.1. After dividing this, what we get? This answer is 0.0409 moles. So this is a molar quantity, and thus this number of moles of benzoic acid is equal to 0.0409 mole. Now second, we calculate this millimoles of same concentration in millimoles of benzoic acid. This number of millimoles of benzoic acid is equal to number of moles of benzoic acid divided by 10 raised to minus 3. That is, if you take consider in numerator, it become multiplying as a 10 raised to 3, that is 1000. So this molar quantity into 1000, just now we see this 1 mole is equal to 1000 millimoles. So this molar quantity into 1000 is equal to 40.9 millimoles. And thus this number of millimoles of benzoic acid is 40.9 millimoles. Thus just now we said, if this quantity is very small, molar quantity is very small, we express in it millimoles. So same concentration 0.0409 moles is equivalent with 40.9 millimoles. Both are the same, only the unit is changed, and thus this figure is changed. Second example, how many numbers of sodium ion, Na plus ion in 3 gram of sodium sulfate, Na2SO4, assuming that it dissociated completely. So this salt when added in water, we assume that it is 100% ionization, and thus this Na plus ion is 100% Na plus ion is released. Given is molar mass of sodium sulfate, Na2SO4, is 142.04 gram per mole. So how we solve this problem? Say this number of moles of sodium sulfate is equal to molar mass of sodium sulfate divided by molar mass of sodium sulfate divided by molar mass of sodium sulfate. So this mass is given, that is 3 gram. Molar mass of sodium sulfate also given, that is 142.04. so this after dividing, what we get? 0.0211 moles. So this much amount of moles of sodium sulfate is present. So this concentration 3 gram of sodium sulfate means 0.0211 moles of sodium sulfate. If this much moles of sodium sulfate added into water, what happen? It undergo dissociation. So this much moles of sodium sulfate when dissociated, it gives 2 moles of Na plus and 1 mole of sulfate ion. See, 1 mole of sodium sulfate gives double number, that is 2 moles of Na plus. When we use this much moles of Na sodium sulfate, what is the moles of Na plus? Double that, this 2 into this moles of sodium sulfate. So 1 mole of sodium sulfate gives 2 moles of sodium ion, and thus this number of moles of sodium ion in 3 gram of sodium sulfate is equal to number of moles of Na plus ion is equal to 2 into this number of moles of sodium sulfate, that gives 0.0422 moles. So number of moles of sodium ion is 0.0422. From where this figure is come? This 2 into this moles. 2 into this moles gives 0.0422. This much moles of sodium ion is present. And that moles of sodium ion, when is multiplied by Avogadro's number, what it gives? It gives the number of moles of Na plus ion. Number of ions of sodium ion. This molar quantity multiplied by Avogadro's number, it gives 2.54 into 10 raised to 22 ions. 22 ions, and thus this number of Na plus ion in 3 gram of sodium sulfate is equal to 2.54 into 10 raised to 22 ions. So what is the formula? How many number of sodium ion is present? This sodium ion number is 2.54 into 10 raised to 22 moles. What we can calculate? Initially we calculate the number of moles of sodium ion, and when this number of moles of sodium ion is multiplied by Avogadro's number, we get the number of sodium ion in that concentration. Third example, how many number of moles and millimoles of 2 gram solute of calcium carbonate? This calcium carbonate, what is given? This atomic mass of calcium is given, that is 40 gram per mole, carbon 12 gram per mole, oxygen 16 gram per mole. How many number of mole and millimoles of 2 gram of solute of calcium carbonate? So first, this molar mass of calcium carbonate is equal to atomic masses of 1 calcium, 1 carbon atom and 3 oxygen atom. We put these masses, calcium is 40, carbon mass is 12, oxygen mass is 16, multiplying it, addition it, what we get? Final answer is 100 gram per mole. So this molar mass of calcium, so in this case this molar mass is not given. Instead of molar mass, what they given? They give the atomic masses, and this molar mass is calculated by summation of atomic masses, and it is equal to 100 gram per mole. Now this calcium carbonate present is a 100 gram per mole. Molar mass of calcium carbonate is 100 gram per mole. The number of moles of calcium carbonate in this 2 gram. How many grams of calcium carbonate present in 2 gram weight? So this mass of calcium carbonate divided by molar mass. So 2 divided by 100, that is 0.02 moles. So in 2 gram of solute, 0.02 moles of calcium carbonate present. This much moles of calcium carbonate present in 2 gram of solute. So one point is clear, that is moles of calcium carbonate in 2 gram is 0.02 moles. Now second, millimoles. Number of millimoles of calcium carbonate is equal to number of moles of calcium carbonate divided by 1 upon 1000, or it multiply by 1000. So this number of moles is 0.02 into 1000, that is 20 millimoles. So this number of millimoles of calcium carbonate is 20 millimoles in 2 gram of solute. See, this 0.02 moles and 20 millimoles are present in 2 gram of solute of calcium carbonate. And the next point, or the last point in this first topic, is a significant figure. So what is significant figure? See, the digit or a number, number in a measured quantity. If we measure any quantity, we express that quantity in digits or number, including all digits known exactly and the single last digit whose quantity is uncertain, called as a significant figure. So see, in this example, if you are taking the weight of any chemical substance on a balance, then record that weight, noted that weight, this number in digit, for example 3.2448 gram. So this last digit in this figure is exactly known. It is assumed that last digit has uncertainty at least the value of plus minus 1. See, all digits are known, but this last 8 having uncertainty, that uncertainty of plus minus 1. It may be 9 or it may be 7, that is the uncertainty. And the absolute uncertainty at least is plus minus 0.0001. What is the position of this 8? It is a decimal, after decimal point it is a fourth position. So it is a 0001, that fourth position, that is a 001 position plus minus uncertainty. And thus this relative uncertainty is this uncertainty, absolute uncertainty, divided by this unit weight expression digit into that ratio multiplied to 100. And what we get the answer? Plus minus 0.0031. This is the relative uncertainty in this measurement. When we measure the mass of any substance on analytical balance, this balance having the uncertainty of plus minus 1, at that time this uncertainty, absolute uncertainty is 0.0001 gram, and this relative uncertainty in this measurement is a plus minus 0.0031. The significant figures are important in various calculations. It is useful for analysis to report any type of measurement. So when we measure any measurement, any observations, at that time these significant figures are very important. In the addition and subtraction operation carried out to the last digit in a significant, last digit is significant for all number is calculation mechanism. See, when we consider this significant figure in addition process or subtraction process, what is the significant figure? See, we take directly example, that is very clear. Take an example having the different decimal point in digits. Suppose we measure this different measurement analysis, we have this observation 0.44, 555, 0.24, this quantity, these three quantities. Now we have the addition of these three quantities, three measurements. The summation of these three quantities figures is 567.23. 567.23. The last digit in significant for all these three numbers is the second decimal position. See, in this case, this point, after point we have 2 digits, after point we have 2 digits. In this third figure, after point we have 4 digits. But the list is a 2. There are two significant, 2 places are very important. These 2 places is this last 3 number in this 3 number, these 2 places are more important. List in this third quantity we have 4 places, but among these 4 places these 2 points are important, 2 decimal points are important, and thus we round up to the 2 numbers. The significant figure, this addition, we round up to the significant figure as a thing. For how this see, when we add these 3 number, 0.44 plus 22.54443 plus 755.24, after addition of this, what we get the answer? This answer is 778.2243. 778.2243. So this is the final answer of this addition of these 3 figures. Now after addition of this figure, what is the answer? 778.2243. When we round up this figure, what we consider? We consider this least significant figure, that is only 2 places. Instead of 4 places, what we consider? 2 places. So 2 is the least, and we consider the rounding up this figure into 2 decimal places. When we route it into 2 decimal places, this 4 is a less than half, so we neglect that part and we round up this figure as a 778.22. Instead of 4, if we have the 6, 5, 53, then we round up it to 23. In case of multiplication and division, so we just now consider subtraction and addition. Now we consider multiplication and division. This calculation contains the same number of significant figure. The number in the calibration is lowest significant figure. So in this case we consider lowest significant figure, that is the highest decimal point. After 0 we can say, for example, see this 18.52 into 0.123, this multiplication. After that we divide it by 2, this figure as a 20.051. After completing this multiplication division, we get the final answer 0.111065. So what are the decimal places after point? 1, 2, 3, 4, 5, 6 decimal places. But when we round up it at that time, what we consider the 3 significant figure. See, here 2 significant, 3 significant figures. So lowest significant figure is the 3 decimal places, up to 3 decimal places, and thus we round up this figure into 3 decimal places and we get the answer 0.111. See, another rules, this round up the final answer, following simple rules are considered. See, this retain the least significant figure if the decimal digit that follows the less than halfway to the next higher digit. See, retain least significant figure. In significant figure we consider the smallest significant figure when it is less than halfway, to the next higher digit. For example, see, in example this point is clear. So round up of this point 117.434. If we round up to 1 decimal place, 0 point नंतर एका decimal place ला आपल्याला round up करायचं आहे. So what we consider, this nearest tenth gives 117.4. This is the final answer. This is the least halfway. How we consider this 4? So as rounding up this figure 0.434, this much part only, point after decimal point 0.434 is less than halfway between the 400 and 500. So this figure lies between 400 and 500. So which is the least? This figure is less than 450. Halfway, when we consider this halfway, it is a 450 halfway. It is less than 450. Yes, it is less than 450, that is 434. And thus we round up to the least significant figure, that is at 4 place. It round up to 0.4, and thus we round up to 0.4. In another example, see, it is increase the least significant figure by 1 if it is more than halfway, opposite to this, more than the halfway to the next significant figure. For that we consider another example, same example, but instead of this 34, what we take? 74. 114.474. Now we round up to the nearest 10th places. At that time what we consider? We consider this halfway. Now this figure 0.474 is lies between these two, that is 0.400 and 0.500. What is the halfway? Halfway is a 0.450, and this figure 0.474 is greater than the halfway. It is more than the halfway, and thus we round up to highest figure, that is plus 1 addition, that is a 0.5. So in this figure we have this plus 1 addition, and we round up this figure to the 0.5. The final answer is 117.5. So we round up this figure to this number. Why this is so? Because this figure is a more than halfway, and thus we increase this number. This figure is less than halfway, so we decrease the significant figure. We consider this figure. If it more than the halfway, we add 1. Suppose these two cases. Third case, what is that? If the figure is exactly halfway, not less than or not greater than, more than, it is exactly the halfway, then what is the rule? See these two figures, 117.450, exactly halfway between the 0.400 and 0.500. Next example, 117.550, it is the exact halfway between the 0.500 and the 0.600. या दोघांच्या मध्ये ही halfway आहे, आणि 0.400 and 0.500 च्या मध्ये halfway आहे. So what is the rule? See, in this rule, the least significant figure of the digit that follows are exactly halfway to the next higher digit. Then this round up the least significant figure to the nearest even number. Nearest even number, समसंख्येला तो round up करायचं. See, this halfway is in between 0.400 and 0.500. What is the even number? 0.400. So it is round up to the 0.4. Got it? We round up to the, see, 400, and it lies between 400 and 500. So what is the even number? 4 is even, 5 is odd. So we round up to it a even number, that is 0.4. In second example, this 0.550, it is a halfway between the 0.500 and 0.600. 0.500 and 0.600. What is the even number? 0.66 is the even number, and thus it is round up to 0.6. So final answer is 117.6. Consider some problem based on significant figure. Indicate how much significant figures on each of the following. Answer is given. You have to study that. You have to solve this problem in your notebook. Practice it. Second, round up the following to the 3 significant figure. At 3 decimal point, we round up this figure. Answer is given. You have to practice it. Report the result for the following calculation to correct number of significant figure. Just now we consider this multiplication, subtraction, addition, division, multiplication. How we round up this significant figure. So these are the example. Answer is given. You solve this example in your notebook and practice the round up these significant figures. Then the second major topic of this second chapter is a solution and their concentration, that we consider in our next video. Solution and their concentration, this topic we consider in our next video. So in this video we complete this first part, that is some important units of measurement up to significant figures. Solution and their concentration, this part we start for the next lecture, next video. We complete SI units, common SI, derived, basic SI units, derived SI units, prefixes, visual conversion, distinguish between mass and weight, mole concept, millimole concept, problem based on that, significant figure, how we calculate this significant figure. This example given in Manali notebook, you practice this example. So this much part we complete in this lecture, and next lecture we consider this second topic, that is solution and their concentration. Thank you friends. Keep go on studying, because your exam, second sem exam, is possibly carried out by University of Pune at the end of June or the start of July, what it may be, but we consider at the end of June. So you should prepare for the examination simultaneously with the progress of syllabus. Thank you.